Hey everybody, as you can see today, we're starting on using Pythagoras and trigonometry to solve 3D problems. Now, just before we get into that, we're just going to go through a quick bit of revision, and that will be just a list of steps we really want you to follow. The idea being we see so many people make so many silly mistakes. For example, they don't draw a triangle, they don't label the opposite and adjacent, but they know it's opposite and adjacent, but then they swap them around and get them around in the wrong way in the equations. So please follow these steps. First step, draw your triangle, marking the right angle. Make sure, it doesn't matter Pythagoras or trigonometry, mark your right angle. Second step, label the angle and the sides that you know or you want to know only. Now, obviously with Pythagoras, you want your A, B, and C sides. Always start with the C, the hypotenuse. If it's trigonometry, if you only label two angles, you're always going to pick, sorry, not two angles, two sides, you're always going to pick the right ratio, okay? Third thing, choose your ratio correctly with whether it's trigonometry, it's going to be SOHCAHTOA, you choose your sine, cos, or tan based on the saying, or Pythagoras' theorem and write it. Write it as a blank, right? Sine theta equals opposite over hypotenuse. Cos theta equals adjacent over hypotenuse, or so on. Or for Pythagoras, a squared plus b squared equals c squared. Please write it like that. After that, you just substitute what you know. Okay, straight underneath it, substitute. You'll see in a minute when we do an example. And then finally, rearrange and solve if you need to, and sorry, rearrange if necessary, and then solve it when you need to, because you always need to solve it, don't you? Put my teeth back in. No. Okay, let's have a look at an example. Find the angle that the diagonal of this rectangular prism makes with its base. Okay, so we have a rectangular prism here. See the rectangle on the end, and it goes across and creates another rectangle on the other end. That makes it a prism. Okay, now find the diagonal of this rectangular prism. So diagonal means from a top corner to the opposite bottom corner. Okay, doesn't matter which one. It could be C down to E, it could be G up to A. As long as it's going from bottom to top or top to bottom. All right, let's put in a diagonal. There we go. I've just done G to A on this one as a diagonal. You see it's going up. Now, we're working with triangles, aren't we? So how do we make a triangle out of that? Well, if you have a look here, that could be considered a hypotenuse, couldn't it? And we come down here and then come back towards here. First thing is we'll put this vertical bit in here. Now we know something about that vertical bit. That's the height of this box. How high is this box? You can see it over here is 2 centimeters. So we'll write our 2 centimeters over there. Now all we need to do is join that up back to G and we make our triangle. Is that a right angle triangle? Yes, it is. Over in the corner here, there will be a right angle. So make sure we draw our right angle in there. Now, that's great. We got a triangle. What are we doing with this triangle? It says find the angle the diagonal makes of this rectangular prism with its base. So that means there's the diagonal, there's the base. So we're going to put just in here, we're going to put our angle. And of course, we normally label it theta. Great. What do we know in this triangle? We know the 2 centimeters over here. We don't know the diagonal down here, and we certainly don't know that along there just yet. But if we find this, we can use this and this, gives us 2 sides, and we can use Pythagoras to finish it off, can't we? If we're finding the side or the 2 sides there, but this time we're finding the angle, so we're going to use trigonometry, but we need the 2 sides. All right, let's put this one over the side for a minute, and we'll keep that for later on. Again, let's have a look at this triangle down here. There's this diagonal. We can make a triangle here across the base. That's a right angle in here, so let's put a right angle in there. We know this side. Actually, I might just bring that down here and we'll have a look at it a bit more easily. There's that triangle down there. We know the bottom end, which is 10 centimeters. We also know this side end here. From up here, we know that's 5 centimeters. Okay, now you can see the right angle triangle, and we can use Pythagoras to find this side here. Here we go. So we're right, we're using Pythagoras' theorem. And remember, write it out as a blank. A squared plus B squared equals C squared. All right, now, first bit, we need to label our hypotenuse, the C. That's the important one to label in this. The A and B doesn't actually matter. A's just popped up there. B down here. Doesn't matter with the A and B. C is the important bit. So there's the B. Now all we need to do is substitute this 5 centimeters in place of the A, the 10 centimeters in place of the B, and we're going to get this equation popping up. 5 squared plus 10 squared equals C squared. So 5 squared is 25, 10 squared is 100. So 100 plus 25, yep, is 125. So that's equal to C squared. Now, we don't want C squared, we only want C. So how do we get rid of the C squared? Right, by doing a square root. So the square root is going to be over on the other side. So it's going to be the square root of 125, which is equal to the C. The square root of 125. Now, if you need to leave it as a surd, you can. Simplify it, of course. But for now, we're just going to leave it as 11.18 equals C. So that would be 11.18 centimeters from G all the way to E. Great. What do we do with that? Well, let's have a look. That green side there is the same as that green side there, isn't it? So we can bring that 11.18. We're going to bring that up over here. All right. Now we're finding an angle. So what are we going to do here? We're going to use trigonometry. First thing we do with trigonometry is label our sides. This 11.18 is next to the angle, it's adjacent to the angle, so that's our adjacent side, which makes the 2 over here the opposite. Which ratio uses O and A? Over here you can see TOA, TOA, tan theta. So write the ratio blank again, tan theta equals O over A. Substitute straight in. The O is 2, goes on top. The 11.18 goes on the bottom. Here we go, tan theta equals 2 over 11.18. Again, we don't need tan theta, we just need theta. So we have to shift that tan onto the other side. I say shift tan. It's actually the inverse of tan or arctan. So I say shift tan because on the calculator, to get to shift to tan to the power of -1, you have to press shift. So shift tan. 2 over 11.18. Now go for your calculator and type that in. You come up with an angle of 10.14 degrees. Now see how by breaking this whole picture up into what you need to finish off with, putting it to the side, then figuring out how you're going to get all the information by getting this from a second diagram. You can just bring it across and do it. Most of these are going to be like that. All right, we'll go through this second one a little bit more quickly. It's not a rectangular prism. Joey wants to roll down from one corner of the grassy hill to the bottom corner on the opposite side. How far can you roll? So that means we're going to go from either up there to down there or over this corner down to here. All right, let's do the first one. Top corner down to there. Now this one hasn't got our corners labeled. That's okay. But straight away you can see we're going to have a right angle triangle here, can't you? So let's put our right angle in. Great. We know this side's 11, but we don't know this side. So we can't work out how far it can roll there. So let's put this one aside. Okay, over she goes. Sorry, I think I'm blocking part of the triangle, but you get the idea. All right, now, so we need to find this side. Oh, hang on, look, this side here. We know the base, we know the height. We can find the third side. Let's bring that one down, bring it out and label it. There's 3 meters there, 4 meters there. We know it's a right angle triangle. So there we go, right angle triangle. We're using Pythagoras. So again, you can write using Pythagoras, but the more important bit is you write your a squared plus b squared equals c squared again. First up, label your c, label your a, label your b. Doesn't matter which one with the A and B. That could be B, that could be A. It won't actually matter. In this case, the A equals 3, the B equals 4. So we'll put them in the formula. 3 squared and 4 squared equals C squared. 3 squared is 9, 4 squared is 16. 9 plus 16 is, correct, 25, which is equal to C squared. Again, let's get rid of this squared. How do we do that? Square root. So square root of 25 is C, which leaves us as 5 equals C. Okay, so we know the C equals 5. Now that was that distance down there, wasn't it? Which is that distance there. Bring the 5 up over to here. There is 5 meters. Now, did we need an angle for this one? No, we were trying to find how far he could roll, how far Joey could roll down that red line. So again, Pythagoras, great. A squared plus B squared equals C squared. Label our C, label our A and B. There we go. And substitute it. So it becomes A is 5. So 5 squared plus 11 squared is a B equals C squared. 5 squared is 25. 11 squared is 121. So all up, that's 146 is equal to C squared. Do the square root, which equals our C. Final answer, C is equal to 12.08 meters. Now, actually, I'll just say one thing. Notice how I haven't shifted the C at all from over there. Even though I just said C equals 12.08 meters, 12.08 meters also equals C. Please don't swap the C around when you're doing your working out. All sorts of errors occur, particularly with negative numbers. We haven't got negative numbers with squares, but trust me on this one. Now, this was a problem, a worded problem saying how far could Joey roll down the hill? So in these ones, it's always a good idea, rather than to leave it like that, just write a quick sentence. Joey can roll for 12.08 meters. All right. Hopefully these 2 examples have been helpful. If not, make sure you ask your teacher to go through some more, but really it is so important to show all of your working out. Okay, write the equations, show your substitution, label all your sides, just do it all. And that way, if something doesn't feel right with the answer, then you can always go back and check where you went wrong. Okay, good luck.